We are back. Second session of today. How's the training going? So close. So close to here. Alright. We'll let that take a little bit longer. Instability is kind of silly. We were going to look at clipping now, right? So I just tried removing clipping from what I thought would be an end where it wouldn't matter. And it totally broke. Hang on, this is with filtering, right? Let's rerun it like this. See if it still breaks. This should only use each sample like one time. Ah, still problems. So, whoops. I guess I was totally wrong there. I didn't think the clipping would make that much of a difference. I figured it would only make a difference if you were running a ton of epochs. Oh, the KL's exploded here, right? 4, 5, yeah, the KL's exploded. Does that make any sense at all? Like, all right, hang on. What if we try, let me try a couple things here. Right, we return clipping. Or update epochs. Giga slow mode. It's possible this is not strictly better, even though it should be, right? T. This looks fairly similar, maybe a little better. So I'll go on record as saying that I thought that I'd looked at the math a couple weeks ago, and I thought that I'd figured out that for the most part the on policy, off policy distinction was a joke. It's not, as it turns out. So the thing that is a joke is that even rainbow seems to be kind of breaking its own math assumptions. It's not like, ah, yes, off policy is the correct one of the two. Okay, so I mean, this is like, this is fine, right? If you crank up the update epochs, you don't really break anything. Yeah, it doesn't seem like you really break anything. Let's check the losses. Let's get rid of this one. KL, flip frac. One bad grad spike. But I mean, otherwise it tracks pretty well, and that's a perfect solve. What happens if you really crank this up? I'm just trying to see if clipping is like a band-aid patch or if it's actually stable the way we would think. This goes. I'm really surprised about the clipping thing, though. Yeah, there's clearly stuff going on here that I do not understand yet. So the thing that I'm not sure here, right, is like, I was kind of looking for just chuck all the methods on stuff real quick to see if anything happens, anything surprising. Like, we did get the big nice boost from Muon. Oh, I see. Uh, Let me check something. What do we clip against? Wait, the PG loss is advantage. New log probs minus batch.log probs. Oh no, that is good. Yeah, that's how clipping should work. That's crazy. So, yeah, the PPO clipping is not a fix or off policy. It's a band-aid. Like, you can still go too far off in just one epoch. Yeah, look at this thing. Can we even see this in the losses anywhere, or is it just bad? Not really, right? Entropy is fine. We're not logging that. Prox Kale's fine. You do see the value loss quite different here. It's interesting. Clipping is in fact essential. Now, it is actually going to keep training on this, and it is improving. I mean, that definitely damaged it. That was an unexpected result. I'm trying to think where we go from there. I really didn't think clipping was going to make a huge difference in, like, one update epoch training. Hang on, what if it's an optimizer issue? Let's go rule one other thing out. Let me just rule one other thing out here. I want to make sure it's not like an optimizer issue. So essentially, if we still clip, but we give it like a really big bounce. Oh. Huh. What? So this is literally like some dumb optimizer thing, right? You don't see a spike anywhere. But like, so we had this thing, right? Where was it? No, where was the run that totally exploded? Yeah, this one, right? We should actually see this in the losses. Yeah, so this thing just blows up instantly. We do this. Get rid of this thing. I mean, it's still like fine with 1.0 clipping. So I don't know about you, but that doesn't strike me as clipping to keep the thing on policy or whatever. That strikes me as like clipping to prevent bad update from destroying the policy, right? Let's try 0.2 real quick because this was the value used in the paper. Make sure there's not something magic going on. It's crazy that you clip the loss and you clip the gradient. I figured that clipping the gradient would be enough to prevent screwy optimizer stuff from happening. But I guess not. Because if you get like a bad advantage, right? If you get a bad advantage, you could take like a 0.5 gradient step in the completely wrong direction. What does this do? Yeah, so this actually, it does a little better than 0.1, but it underperforms 0.5. Let me see what these clip coefficients actually do. So these clip coefficients get applied. Yeah, it's this like ratio clipping. Okay, this is directly on props. Yeah, this is logit space clipping. So it doesn't let the old log props get too far away from the new ones, okay? And then the gradient, there's also the gradient clipping. And then the value function clipping is this one's weird, right? Yeah, this one is just like directly in you're literally just plus minus a constant on the value loss. That's crazy. Oh no, it's clipping the value loss to plus minus this constant. Yeah, okay. Does this thing get normed? This doesn't get normed at all. Probably should be normed. So where do we go from here? The fact that this has like such a wide window Kale's kind of bad at the same time, isn't it? Kale's like kind of bad. Let's go back to the old replay buffer. Let's set this to 1. Set this to 1 and see what happens. So this is now potentially like massively off policy. Value loss is super high. Okay. Let me try one thing. So now we define this mask. I mess up? Try that. Seriously, it's still no? Ah. So now this is not training the value loss on stale data, but still training the policy. Looks like we still get stuck. Oh, we still get stuck. The value loss still blows up. Maybe marginally better. Okay. So let's not do that. Let's look at V trace. Okay, so this Impala paper is also what introduces V trace. Do they have an ablation with and without V trace? Before I read this thing. Yeah, there's a big difference here. Big difference. Ah, and you see with the replay, so this is what gives them access to this replay buffer. So this is kind of exactly what we want. The V-trace targets are defined by 1. Okay, over here. Off-policy learning is important in the decoupled distributed actor-learner architecture because the lag between actions are generated by the actors and when the learner estimates the gradient. Yes. Consider a trajectory XA reward from S. So this is perfect. This is exactly what I have. We define n-step v-trace target for the value function. Sum over the trajectory segment, gamma, some crazy product to TV. Okay, this is, I think, the thing that is worth investing into right now. This is the thing that's worth investing into. We also should open up, let me switch the view, because we need to, this is going to get heavy. Okay, so here's our current target from generalized advantage estimation. Sum gamma delta. They have this product, and then they have delta, and then they have V. Delta TV is PT reward plus, okay, so this here is this not this? Xt plus 1 minus xt. But this is only a one step, right? This is literally only a one step. PT is min, is this average? Okay. Truncated important sampling weights. In the on policy case, when pi equals mu, and then you get the on policy n step Bellman, which is right here, which is lambda equal 1. So this thing recovers that. On policy n step Bellman update. I was going to use the same algorithm for off and on policy data. Truncated important sampling weights, CI and PT. Well, this is, what is this? Rho or something? I actually don't remember. A. I know that pace weird. Whatever. To TV. Okay, we don't care about the tabular case. V-trace targets can be computed recursively. Did this one come with source code? Yes, this one did. Though it's probably in TensorFlow. Oh, they gave us this. Jeez, okay, this is actually, it's row. That's what it is. It was row. They have this and they have a test for it because this is a very important thing to get right. Okay. Let me just briefly look up if there's been any successor to vtrace. Phasic policy. People were talking about this, right? Oh yeah, this is Schulman's follow-up to his own stuff. Oh yeah, this had the weird thing where so this thing did better for them. Choosing the optimal level of sample reuse is not straightforward. Policy and value function training are decoupled. We can train each with different levels of sample reuse. In order to better understand the impact, we chose to vary the number of policy epochs without changing the number of value function epochs. That's actually very similar to what I just tried to do. Get out of here, bot. I build the bots around here. Single policy epoch is almost always optimal or near optimal in PPG. This suggests that the PPO baseline benefits from greater sample views only because the extra epochs offer additional value function training. But isn't the value function data what gets off policy? I mean, it is also the supervised one that you can train perfectly, right? So that doesn't suggest that you can reuse samples, right? Oh, okay. These are literally inverted. Okay. Man, I love when I just have, a whole day to just get as deep into the literature as I need to try to understand stuff. This is good. Too many epochs runs the risk of overfitting to recent data, not with a giant batch. Fewer epochs will lead to slower training. From 1 to 9. Training with auxiliary epochs is generally beneficial. Up to 6. We may expect better train features to be shared with the policy, or train a more accurate value function. The feature sharing appears to play the more critical role. Auxiliary phase frequency. We investigate alternating between policy and auxiliary phases at different frequencies. We perform each auxiliary phase after end policy updates. Performance suffers when we perform auxiliary phases too frequently. As an alternative to clipping, Schulman, that's a me, this guy's own paper, proposed using an adaptively weighted KL penalty. We now investigate the use of the KL penalty in PPG. Instead, choose to keep the relative weight of this penalty fixed. Okay. Fixed KL performs remarkably similarly to clipping when using PPG. Clipping is more important when rewards are poorly scaled. Great, I don't have to do a bunch of math. Lovely. They want to keep the KL penalty for the theoretical insights, even though it's a pain in the ass. It's funny. Default implementation of PPG in a single network variant that mimics the same training dynamics. PPO shown for reference. PPO, PPG, PPO single. They're very similar. PPG comes with an increased memory footprint. Since we use disjoint policy and value function networks instead of a single unified network, we use approximately twice as many parameters. We can recover this cost by using a single network that appropriately detaches the value function gradient. What? During the policy phase, we detach the value function gradient at the last layer shared, preventing the value function from influencing shared parameters. In the auxiliary phase, take the value function gradient with respect to all parameters. Okay. I think they did some, whatever, that's fine. Related work, conclusion. Very good. Okay, do they have algorithm pseudocode somewhere? Yes, they do. Initialize empty buffer. Perform rollouts. What's vtarg? Value function target. I missed this? In vtarg, computed with generalized advantage estimation. Same objective from PPO. So this is just PPO, right? So perform rollouts, compute value function, optimize the policy for some epochs, optimize the value for some epochs. That is twice as expensive, right? Wait, and then there's L joint and L value. Okay, I don't think I fully understood what the heck they're doing here then. We optimize the policy network with a joint objective that includes an arbitrary auxiliary loss and a behavioral cloning loss. What? L-aux. Hold on. You don't need this if... Wait, let me try the single... What's the single one? By default, PPG comes with an increased memory footprint. Since we use disjoint policy and value function networks instead of a single unified policy, we can use approximately twice as many parameters compared to PPO. Recover this cost by using a single network that appropriately detaches the value function gradient. During the policy phase, we detach the value function gradient at the last layer shared between the policy and the value heads. Preserving the value function gradient from influencing shared parameters. During the auxiliary phase, we take the value function gradient with respect to all parameters. Huh. Okay, so that's not quite. But then what does the auxiliary phase do? Hang on. So they just do, where's the pseudocode? Optimize the clipped policy loss. Optimize the value loss. Optimize L joint. Optimize L value. Okay, I don't understand this thing. Perform rollouts under current policy. CleanRL has this, doesn't it? CleanRL should have this. I thought they had PPG in here, didn't they? PPG ProcGen. Policy phase. So they collect rollouts, right? Optimize policy and value network. There's the policy network one. And they do these at the same time because they're separate networks. Okay. But then there's an auxiliary phase. Hold policy. Need to understand this, need to understand B-trace today. Those are the two goals. What's this BS? What's this extra thing? That's just entropy. So in the first phase, this is just do PPO, right? Yeah, this is literally just do PPO. With a stop grad, potentially, if you use a shared network. Okay, so that's super easy. And this is not even slower. This is not even slower than PPO, provided you use the shared formula. But then there's this EAUX, where you optimize L joint and L value. So what is L joint? We optimize the policy that has an auxiliary loss and a behavioral cloning loss. So this is the value function loss. Okay, so in the shared version, the shared policy version, this is literally just train the value loss. And then this thing here, behavioral cloning loss. KL, this is just a KL term. Policy old. Oh, okay, I understand this. So they're trying to keep this thing outputting the exact same actions, while training it to match the value targ. I see. That's clever. Let me think why that makes sense, though, to do it this way. Let me make sure I got the this is V theta V. Yeah, this is theta V. Do you even have to do this, I wonder, with the shared formula? Like, this is arguably not even that hard to do, right? This seems orthogonal to V trace, though. Now that I understand this, let me go back through the experiments again. Where's figure 3? We chose to vary the number of policy epochs without changing the number of value function epochs. Results are shown in figure 3. Holy. That's wild. So that's literally just train the policy less. Okay. And then they get literally the opposite with the value function, right? Lagging value function then. And then here is the auxiliary phase frequency. Additional epochs during the auxiliary phase. So you don't actually have to do this very often. Wait, we had how additional epochs during the auxiliary phase. Oh no, this is the other way around. Okay, wait, this is the frequency. E aux. Hang on, this is E pi. E aux. Pi. So they didn't do this. I thought they did do this one. So this one is E pi. No, this is not EV, this is E aux. And then the frequency So this is not that bad then, because you do have to run some extra epochs, but you don't do it that often. This thing is probably pretty awful though for M speed. You can't really do anything on the end while you're optimizing that. Eh, that's okay. Okay, so I understand this thing. I think this is going to have no bearing whatsoever on vtrace. So this is something to investigate for sure. This seems like a pretty strict generalization of PPO. Okay, so that's one. Now we go to vtrace. Not this one, where is it, vtrace? And now we try to understand this vtrace target. Value at state sum this product s to t minus 1. Sum I equal s to t. Yeah, so this is fine. This is actually easy to compute. Then ci pi over mu. Okay, and then this delta is just td. They have a q function in here. See it in here. Hmm. 21 billion frames per day, 250k FPS on 500 CPUs. Oh, and then you actually have to divide by 4. Yeah, so this is actually 60K. Yeah, that's about what you can do with a GPU. That's funny. That's actually a pretty disappointing perf, looking at what Puffer does these days. Because I can give you half of that just like out of the box with like what, 16 CPUs? So, okay, in order to implement this thing, let me go check my current implementation. So that's the current, no, it's in shared. Okay, so JE is just rewards plus gamma value minus that. So this, write this. Okay, this is all that this is. Delta plus Oh, I'm covering the screen. Hang on. We'll do this for now. If you get rid of this term, then you can literally just do this, right? Yeah, it's just the sum of these. And then you don't even have the lambda term, right? So really, I just need this rho term and this C term. So let me see if I can understand these. Rho and C are truncated important sampling weights. Where did they define? So mu is the original policy. So this is pi old. What is this min p bar? Right, LPV trace. P bar as a truncation threshold. Oh, is that a constant? That might just be a constant, right? That might literally just be a constant. If that's just a constant, this isn't that hard to implement. Where do they get a P bar though? Are these just parameters that are going to be listed somewhere for us? Hypers? Any hypers? Are those not just fixed hypers? Because I don't see them anywhere. Discount. Let me see. Oh, one. Okay, so if that's correct, those are literally just one. Okay, now let's go back one more time and see if I understand why this is the way it is. So this is, there's no lambda in here. Let's ignore lambda. So discounted, so we're just doing Bellman, okay? No exponential smoothing with lambda. Value plus, so if we ignore this piece here and this clipping, then this gives us Bellman, which is this right here, and stout Bellman. So what we're saying here, let's do this one first. This one's easier. Ah. So we are clipping, we're clipping the advantage, or rather we're scaling the advantage based on importance sampling instead of scaling the policy gradient loss directly. Oh, that also scales the value function target, doesn't it? Important sampling is embedded in the V-trace target. Corrected value estimate indirectly influences advantage computation. By correcting value function, V-trace ensures advantage accounts for policy mismatch. Is not directly applied to the advantage itself, it's the value function that is adjusted. What? Is this the advantage function they use? That seems weird. I gotta check that. Advantage and value loss. Clipped objectives for the policy loss, typically unclipped, or L2 loss for value function. No, there is important sampling, right? The clip is on a logic ratio. Relies on truncated importance weights. Okay. So you might not need a lambda parameter. Because lambda pushes you towards one step, right? If you add, yeah, because lambda is one default. So yeah, this just pushes you away. Lambda just pushes you towards this, which is really easy to optimize, but this is like a one-step bootstrap. So this is hard to optimize, but it is correct, right? More correct. This is the end step, or the infinity step. So you might not even need a lambda term. Okay. It is not more common to see unclipped value loss in PPO. That is not true. Corrects the value function. Now let me just see what they use for the advantage function here, because I'm a little suspicious now. So here's your V-trace target, which is what you train the value function against. Now where's your advantage function? Let's make sure I understand this as well. Okay, hang on here. So this is just the value target. Did they give us the advantage? Gradient of the value function, whatever. Oh, what? That's all they do? Hang on, this is the V-trace target, right? Oh wait, no, this is the same. Isn't this the same? Because advantage yeah, you add BST to this, right? So you do VST plus this, which if it's equivalent here, R plus lambda VST plus 1. But that's the one-step version, right? No, it's not, because this is reward plus advantage. Let's see. Yeah, okay, that's still fine. That's the same. So this is actually a very sort of similar method. What did they benchmark this against? What is their no correction? Is no correction generalized advantage estimation or no? No off-policy correction. Multiply advantages by corresponding importance weight. That gives you very similar performance. Without replay, it gives you very, very similar performance. With replay, there's a bit more of a gap. There's no benchmark of V-trace versus generalized advantage estimation. Probably worth implementing this thing still. I say we start on this. This thing needs values, rewards, dones. Call this trace. And then this also needs importance. And then we need float row float C. Okay. And this is going to be fairly similar-ish to JE. Let me see this double loop real quick. This is T goes from S to T minus 1. So this product is pretty easy to compute, isn't it? It's just one term per. Okay. So we do float C product. Does this one go backwards? Wait, does this one go backwards? This one can't be computed backwards, right? That's a little bit annoying. Wait, this is AT and this is AI. But this is CT. So this is the same thing. Oh, you missed horizon. Has to be 1 to start. Rod. This is clip. Clip. Something like this, I believe. Min, max, importance. You do prod times equals this. Or actually, we can do it the other way, right? So we do prod times equals this. And then this. So now you have all your products. Okay, so you do this. You only need this component, right? You don't need this extra exponential smoothing. Wait, this is rewards of T next. Is that right? That seems weird. Is that a bug in GAE? In my GAE? I think that might be a bug in my GAE. This index and the negative are the same. And the values. Yeah, that looks like a bug to me. We will play with that. Okay, so cool. I think we can just start implementing this portion now. To be so careful with this. We'll start with this delta. So this delta is just equal to reward at, I'm going to make this T, values, gamma values T next, minus values. Okay, so this delta is fine. This is just a backwards sum, right? So I can just do like float term equals 0. Let's do a cum. This is not of T next. This is of T, right? This is T times delta. Okay. Next non-terminal. That starts out at 0. So we do accum equals C prod delta plus gamma times next non-terminal times accum, and then trace of T is equal to accum. I think that's it. Except I missed the, what's this, the row clip? Ah, shoot, you missed the row clip. You clip twice like that. Clip. This is not it, though. It's not, this is importance here. Let's just do row sub T, Yeah, so this is it here. So this is the clipped row. And then this is row clip delta. And then we can do this one in line, I think. So this one should be so this is this has to go here. And then this is actually row sub T times all this. I want to keep it as close to the math as I possibly can. And then this is prod T. Okay, let me think about this. Is there no value function bootstrap on this? No, there is, right? Yeah, there is. So it's going to be delta, accum is 0 at the first time. So C prod delta plus gamma times that. I think that's correct. Let's see if I can get this thing to compile. I'm going to actually move this. I'm going to move this. I move this down. this down. I mean, this should basically be auto-completable. It's so basic, right? The check on this. Rewards done's importance. Num steps. Trace. Row clip. Yeah, there we go. So then we just do rewards, values, done's, importance, and trace should all have the same dimensions. It should be 2 dimensions on the same device. Horizon, float 32, not contiguous. Oh, you don't pass in trace. My bad, you don't pass in trace. Right. Now we do tensor trace. Like this. Okay. That's the shared file. Now we need the bindings. And this is actually, believe it or not, this is going to be the C++ and the CUDA at the same time. Should be very nice. We'll do the C++ bind first. Vtrace, values, rewards, done's, importance, advantages, clip, num steps, horizon. Set plus equal horizon, vtrace row, importance plus offset. Okay. Trace plus offset, row, clip, horizon. You missed gamma completely, man. What the heck is wrong with you? And you use it here too, don't you? Yeah, gamma. What's wrong with you? Load gamma. Load gamma. This doesn't need to get checked though, right? Like the check on this doesn't include any of this crap. You just need this, man. There's one extra tensor and you're good. Okay. Now the actual function here needs everything. Float trace, float gamma. All right, and then you do vtrace, gamma, with the horizon. PufferLib, CU. Is this the right one? Yeah, I think this is the right one. So we need GAE kernel, I believe. Okay, and then there's compute GAE. So we'll just do this. Vtrace kernel, which takes values, rewards, done's, star importance, star trace, gamma, load row clip, yep, all that. And then it's just vtrace with the new args. And then that will give us our kernel. We still have to bind this thing. So let's actually put this down here. I don't know why I did this way. This should go, what is this thing? Yeah, I don't know why I did it this way. This needs to go down here. You go there. All right, vtrace kernel now. Just needs a binding, which passes in everything except, yeah, perfect. That might have just one-shot it because this is super basic. Let's see. Vtrace check. Yeah. Oh, gamma clip. That looks good to me. Just a bunch of boilerplate. And then we just have to export compute vtrace. Vtrace. Cool. Use vtrace is false. These are both 1. We do. Please. lfconfig use vtrace. We vtrace. We missed gamma. You do need gamma still. Did we get that in the signature? Yeah, we did get that in the signature. Okay. Well, you don't give it experience.importance, right? Yeah, so this is like, what you need to do, this needs to be importance. And then we have to do how do we do this? We need old log probs and new log probs, right? Does this thing prevent you from doing prioritized replay? Because wait, you need to have this says that you need to have the importance ratio before you compute advantage, right? How does prioritized experience replay work? Maybe we can just use something else to sample it with, and then we don't need advantages. I don't have mental bandwidth to read another full paper here right yet. Hang on. Let me just think what we can do in the meantime. So oh, I see what we would do. So we would just do advantages equals port.ones. Okay, so then we would sample our batch. So this is now uniform, right? Then we do if config use vtrace, we need to compute JE for this batch. So this is going to be batch rewards, guns, config gamma. Okay, and then we do importance equals is it this ratio right here? Ratio, right? That is the important sample. Oh, I totally messed this up. Hang on. Yeah, I know how to do this now. Okay, so we do this. Advantages towards ones. Then we go down to here. And we say all right. And then this importance is just ratio. Okay. Advantage. Advantage. Or what's this? This is not advantage. This is vtrace, right? vtarg. And what's the vtrace paper make me use for the actual policy? What they use? So this gives you vs. Okay, value function is easy, right? Yeah, value function is easy. This is just batch.returns, right? Batch.returns. So that's an easy target. Now, what do you do for, the only thing I don't know is the policy. Policy, it says you do R. Why is it VST plus 1? Is that a thing? Let me just do something to start. Oh yeah, this log ratio is, yeah, gonna be completely different, right? So it's gonna be PG log new log prob times batch dot gamma batch returns minus batch values. I think this is it. I think that is it. And then we have to say might turns at next step. All right. 0 chance that this runs on the first try. Oh, I also, unless I forget to enable it. Ah, this is a bad caching. There's a bug. There. Let's see what that builds. All right, how many bugs we have? C flip, row flip. You just straight up forgot to add this. Yeah, that was stupid. Gamma lambda. Not bad though, that will immediately have a CUDA kernel for it. So if it works, it'll also immediately be fast. Can I just do const? Can I like const interize it? Can I just pass this? Host redefined. Cannot be used. I just have to get it so that this thing will let me use this for a static array. Expression must have a constant value. Guess I can't do that. That's very obnoxious. Why did I need to do that again? I absolutely didn't need to do that, right? No, I do need it because... Oh, that's super obnoxious. Hang on, what's this define? This is const. Btrace. Compute btrace. Is that it? Come on, it's const all the way down. Typing stupid CS 101 to Grok. Horizon is a what is I mean, I can't mallet it. That's a total pain in the ass. So I think I know what we can do. Something like this. All right, that actually compiles. No attribute compute vtrace, yeah? This is probably just signature, right? Okay. 1, 2, 3, 4. 4 tensors. 3, 4. 4 tensors. Gamma. V trace clip clip. So float float. Float in 2 ints. Should not be 2 ints. Not be 2 ints. V trace. You do not need to pass num steps or horizon here. These are computed steps. That's what you get for autofilling. There you go. I'm gonna use the restroom. I'll be right back. Okay. What did I pass wrong? 1D importance ratio. Yep. Yep, that's it. Red cannot be graded yeah, okay, interesting. Oh, dummy. And this is a mismatch as well. Yeah. New long prop. Shape. Do some shape fixing. I just want to get this to run. Oh joy. CPU fallback maybe? No attribute compute vtrace, really? Compute vtrace was not declared. Well, yeah, because I didn't declare it. Alright. Values, rewards, done is important. Gamma clips. Trace. Set. Data rewards, done is important. Trace. Gamma row C. No steps. Horizon. So much binding code, man. So much stupid binding code. I mean, it runs. We've got, I'm assuming I'm not timing this thing correctly. Alright, that's really freaking slow for some reason, but it doesn't train either. The CUDA one is somehow out of memory. CUDA one somehow legal access, really? Well, it's the same bloody code, so how do you figure that? It worked the first time? So eventually this thing errors somehow. And if I don't do this, do I still error? No, then we train. Against who knows what we're training against. So it is this thing. Values, rewards, duns, ratio. I need to do this. No, it doesn't help. Compute vtrace. Anything out of bounds looking. Oops. We got max horizon, right? Yeah, I don't see anything that would be wrong there. Vtrace kernel. Oh well, this is really stupid, right? Or no? No, this is fine actually. JE kernel. Row times horizon. Values plus offset. Rewards offset. Done. Gamma lambda. Horizon. Does this use num steps? Doesn't even use num steps. Horizon's not longer than 256, right? I'm pretty sure it's not. Okay. Not that. Host and device stuff. I mean, we should probably just look at this very carefully. Gamma, clip, right. So we're passing these all in the correct order, I'd assume, right? Num steps, horizon. So then horizon goes to vtrace kernel, and then goes to vtrace row, gamma, horizon, vtrace row, horizon. Oh, what the heck is this? How'd that happen? I don't know how that happened. See if that does it. No? Still found legal memory? Really? Let me see. Less than horizon? Not recompiling it or something? Should be. Let me clear the cache just to be sure. That's bizarre. It runs on the CPU, it doesn't run on the GPU. Why do I think it's gonna end up being something stupid that's like not even here? Because I don't see anything here, right? You have this buffer's always big enough. Starts out at 1. You go from 0 up to horizon, which definitely fits in there. Importance is also the same size. This is assert checked. Right? This goes to -2. So this is -1, which is fine. T. And rewards at T. Values T next. Prod T. Horizon -2 to 0. Still fine. Trace of T. Yeah, I don't see anything wrong with this thing. It gives you num steps by horizon. You've assert checked all of these, right? Does this give us anything? That's not going to recompile. Blind debugging is just such a stupid thing. Yeah, it's just going to give me a legal memory address. There's nothing useful in here. It's all asynchronous, so you're just screwed. Does the synchronize even happen? Let's just make sure there's not something like ridiculous. No, we still get a legal memory. See, I don't understand how it actually doesn't happen. Like, we don't actually even hit it here, right? We hit it in one of the frickin' profilers. You would think we should hit it here, right? Like, how am I not hitting it there? Are we hitting it in the sample or something? Like, where are we hitting this? Samples with advantages? So this doesn't get called at all. I guess it could be this sample up here, but that wouldn't make any sense at all to me. It's still just in a wrapper somewhere. Right? Okay, what if I do this? Nah. So literally somehow, because this is not even doing anything, right? I mean, I could just like, for the hell of it, .clone. Clone. Right, we could do all this. No, so it's literally like freaking CUDA, man. Duns is float, right? I'm sure that Duns is float. I will double check. We literally pass it, yeah, experience.duns. Just make sure. Yep. I don't think this is in place, right? Could be, that could technically be something. Hang on. But I don't see how it would be. That doesn't make any sense. Contiguous. I'm pretty sure it's not that. Yeah, no, it's not that. How big was the array? Oh, you idiot. Okay, I know it. I know it. Damn it. Alright, that's me being dumb. I should have added a check for that. Moron. Cert. What is it? Num steps. Yeah, there you go. Let's put this in compute J as well. I forgot that because I'm applying this to samples to mini batches essentially, you can't have as many threads. So it was trying to split it. It didn't have enough data for a full block. Yep, there we go. So stupid. Alright, now we still have the problem of it not training. But at least now we can debug working code. I'm way happier debugging working code. We can see the grad variance has just exploded catastrophically. Oh, that was obnoxious. That was a silly mistake as well. You would think you would get some kind of error for that, but nope, you don't. You just don't. You get out of memory, or like memory access, whatever. Okay, so the value loss seems pretty damn easy, right? Like this seems pretty basic. Now this one potentially, this has important sampling on it. I missed this. What's this row? Important sampled, right? So that row is just ratio. What's the objective? Why don't they write the objective here? Just want the freaking B trace loss. Where is it? TensorFlow code, man. Something here. Still in progress. Literally, top is some random repo. What is the right row log This one's easy. What's this sum? The hell is this sum? Where did it get this formula from? Yeah, that literally makes no sense. Okay. Um, Logic's actions advantages. So this is wait, what? Cross entropy times advantages. I like how it's trying to tell me that in the original implementation it's this way when I pasted the original implementation. So I literally pasted that. Assuming that's not like some other baseline, right? Doesn't look like it would be. Btrace returns.pg advantages. Loss. this it? According to the paper, that's what it is. Expected. Is this not the same as, hang on. Is this not just new log prob? I think we need to go look at what their vtrace outputs. Yeah, we need to go look at what their vtrace outputs. This is not working. So they literally just do cross entropy, advantages, and then this is vtrace returns dot pg advantages. PG and okay. Oh, this is some like crazy scam thing. Cool. It says this is their from importance weights. Discounts. They pre-compute discounts, I guess. Strip value. BST+1. Okay. Antigens equals words. Returns of star gamma batch returns. Is it batch values? Can it not be this ratio? Okay. Brad can create it only implicitly for blah 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 blah. All right. Really? Okay, you know what we're gonna just do? This is gonna be add whatever the stupid thing logs. Whatever it logs. Okay, well, this clearly still doesn't work. Flipped PG rows. Hang on. They have like two different things that this function is returning. We'll know when we get it because they should at the very least be competitive with what we have before. What we had before. And it should basically not work if it's wrong. It's so weird how they like export. Like they've got VS, and then concat. Yeah, so they do one extra bootstrap value at the end, which is such a weird way of doing it, but whatever. But then they apply, hang on, it's clipped PG rows. So I think you need to return two things from this function, don't you? I think you just need to return two things. Clipped PG rows equals if clip threshold rows where's row? See the math? Okay, so here are your rows, right? This is something that we compute. Yup. This is something that we compute. Times. Well, this is just this is literally just the ratio, isn't it? I think the easiest thing is just going to be to put this entire thing into the kernel, right? The thing is, you miss one at the end. With the way that this is written, you literally do miss one at the end. Let's see. This clipped PG rows is literally just a clipped row. Yeah. Here's your clipping. They do the clipping differently though, don't they? Why is their clipping like 0 to 1 or whatever? But you can't freaking use I don't even know why I opened these models when they're wrong in the first sentence. Like literally just close Twitter. Like, oh, models are coming for everything. The models suck. They're all stupid. This ratio is still what we want, though, isn't it? Log ratio. Flipped row. Min. Frankfurt min. Oh, you can just do max. Lamp. Okay, so that should give you clipped row. I think that's the same. And so it's this advantage gets multiplied by rewards plus discount discounts times batch returns next minus values. Okay. So I have this term, but then they take this against the softmax. Maybe I should just do that. Flipped row times. Okay. Which Q with Z indices, which logits with indices. I'm gonna have to find like a good reference implementation. Logits. Yeah, there's like no way to freaking do it. We do like logits. Expected target size. I'm just trying to get something to like match the reference. I think I'm gonna just have to find a reference implementation because the original sucks. It's like stupid dated TensorFlow code. This is not going to magically start working, right? For a second there, maybe. But no. Okay. Is there an Impala PyTorch imitation? Mono Beast? Oh, they actually have this thing that they use for NetHack, right? Is the whole trainer in C++ for this crazy thing? Okay, so this is similar. Maybe we can do something with this. Okay, so this is, they have vtrace returns, and then they call vtrace, so vtrace.fromLogits, then they do advantages times this, and LL loss. Okay, and then their vtrace here. No, is there vtrace in Python? No, it's not. It's okay. It's like weird torch code. Fine. Yeah, okay. So from logits here. Okay, hopefully we can figure it out from this. What do they do it from? They do it from logits or whatever? From logits. It's probably easier. And yeah, there's also outputs two things. Okay. From logits just calls from importance rates. Cool. So this does log probs and then subtracts. So this gives you log rows, which is literally right here. So this is log rows. So you give this log rows, and then it does exp. Yeah, so this ratio is literally just rows, right? And then they clamp rows. And they torch.nograd starting from this line, actually. Okay. Clip the rows. Append bootstrapped value. Kind of wonky that they do that. I guess they were matching the reference implementation. But, like, fine. Deltas. Flipped rows. Rewards plus discounts. That is okay. That looks... Wait. The heck? Okay, so here's their result here, right? Vs minus V. And they add values. They add the values here to get Vs. Broadcasted bootstrapped values. Clipped PG rows. I thought we already did that. Oh, cool. They just had a separate threshold. And then here are your advantages, which is clipped PG rows times rewards. Okay. I think we should be able to use this as a reference. This is like at least way easier to follow. So we have our row sub t. Okay, so this is row sub t, clip PG row, times rewards, discounts times VST next, minus values. Hang on, that's the delta. Okay, so this is deltas, right? Clipped rows. Okay, so we get this delta. And then the accum deltas of t plus discount times deltas C prod times deltas times accum. Is that it? I might have this wrong. Hang on. Complicated. Right. Don't need too much space of this. We just need this little window. Okay, so they do this product times this delta, right? What's ac? Accum. So yeah, this is my accumulator. Discounts. Did I do this wrong? This might be C. I'm gonna have to move this delta, right? For this prod. This is C prod. Like this. Yeah, so this is the backwards iteration that I'm doing here. So deltas of t, which is right here. I just computed delta. My delta is the same as theirs. We might have screwed up the last value, right? But so far, this, other than that, this is fine. Add v to get vs. Add v to get vs. What? Add v of x to get vs. Well, what do they use vs on? Baseline loss. Yeah, so this is value loss. Let's first modify this thing to do to have two inputs. So this should be vs and advantage. So let's actually modify the signature. Advantages. So this is going to be vs float advantages. Okay. And this is importance. Does C++ do multiple returns? Nope. In that case, then we will just we'll move this. So this v trace check. Oh, you can't return it from PyTorch then either, can you? Yeah, that's super annoying. I mean, we were probably gonna just eventually pass it in anyways, right? Advantages. Yes, advantages. Okay, so we get VS and advantages. And then we pass in VS and advantages to the kernel. Yes. All right. Cool. This is advantages. Ratio. Yes. Okay. Let's modify this. It's in here. So this is now so we get this accum. So we just do VS of T plus values of T. And then the PG advantages T equals this does not use VS. VS T plus 1. So rho T times rewards T plus gamma. And this is not values. This is VS T plus 1 minus values. Bs at t plus 1. Isn't that just you put this here, right? Isn't that you just put this there? Okay, let's get this to compile and then we'll screw with the formula. Right? We're getting close though. We're definitely getting close to this. I hope it works. I mean, like, I hope the correct implementation is actually good. Okay, vtrace check. Importance. Steps horizon. Yes. Trace. Don't need this anymore. Error building. PufferLib. And now this is void. Okay, cool. These KLs are crap. It's funny this is not immediately exploded. So we should actually just be pretty chill right now, right? This should literally just be like something like this, right? Advantage. And then was it like batch dot returns? BS, maybe? New value minus returns, yeah. That's it. Do we have to do this like weird shift thing anymore? I don't think we do, right? Can't we literally just do like that? Isn't it just this? Yeah. GT, shape. What's this? -1. Something like this, right? The first few logits being 0 is weird as hell. We should probably investigate that. I almost expected that to work. Almost. Okay. So, here are your advantages, right? Got your VS. Let's see how they implemented it. They have this loss here. So they did it as NLL loss. They summed? That's crazy weird. Try that. This thing run? Okay, now I have it implemented the way that they have it implemented. Right? Compute policy gradient, compute, let's see, PG loss. And then they sum and there's no negative on this thing, right? Yeah, okay, so this is good. Value loss is super low. Well, because there's nothing happening. It's predicting zeros. And the KL's blown up. Presumably something is wrong there. So let's see, let's go back to this then. vtrace returns. Let's go through this thing with fine-tooth comb, right? So these C's are clamped rows, right? They also did this like shifted array thing, no big deal. And their deltas, clipped rows. Yeah, so this, we have this as well, right? And then this is not how I read. This is not how I read this CS of t, right? Is this correct? That would be a major discrepancy. Let me see. So they just get rows from this log ratio here. They clamp them, CS, make no changes, and then, yeah, here they have this. But in the paper, where'd it go? Was it Impala? So in the paper they have, where is it? Is this product not, hold on, there's a recursive formula for it. Vtrace targets can be computed recursively. Okay, so this is the formula they're using, right? CS. And CS is, okay, so this is the formula that they're using. And let me compare theirs to this. So they do V XS delta SV plus discounts CST times AC, which is VST plus 1 minus VS of t. Oh, because they have this minus values here, right? Okay, hang on. Let me see if I can align it with this then. I think there's like several things screwy. So we're not going to need this at all. We are going to need clipped CS. Which is really CT. Float CT. Clamp rows. And then clipped rows. Yeah, these can technically have different clip thresholds, right? They don't, but they can. Okay. So then what we do is we get our delta. We get our deltas is going to be They said they define this as clipped rows. Hang on. I want to make sure we get the mathematically correct definition here. Where'd the paper go? Dang, where did I put this freaking PDF? I'm going crazy here. Okay. Rho equals yeah, it is the clipped thing. Okay, that's fine. So rho delta is equal to rho t times rewards plus gamma times values times next terminal minus values. Then advantages is equal to do. Hold on, this accum first is deltas plus gamma CT next non-terminal times. Okay, so gamma times C times accum times next non-terminal. Right. And then VS is you add values to this, right? To accum. And advantages is rho times rewards plus discount. This is VT plus 1 minus values of T. I think this is correct. And we'll say, I think this is correct. We're going to be able to remove this whole product thing as well. So this ends up not actually being that bad code-wise, right? See, I thought we had it. The value loss is low. It's the KL that's screwy, so presumably I'm still optimizing that thing wrong somehow. Policy loss, yeah. Let's go through it again. You put your importance ratio, which is this X, right? What do you pass in? You pass in ratio, right? Ratio. Values, rewards, dumps, ratio. Okay. So you get your rows, which are just clipped to max. Yeah, this is exactly how I was doing the clipping. Wait, F max. You have this backwards, don't you? This is F min. You don't need to clip. Yep, your clipping is wrong here. This is F min. Your clipping is wrong. Every time, every bug is a little closer to having this thing working. All right. So min. Yeah. And that one. Okay. Oops. Now we try again. Every time. It's like, oh, it's optimizing. Nope. You can see from the KLs are all screwy. And keep looking at this line by line. Delta, row, reward, discount, next value, terminal minus values of t. And then accum, deltas of t, delta, discount, CS of t, ct, accum, next non-terminal. Do you need next non-terminal here? You do, right? I believe so. It would make sense from this. This gives you Vs minus V. You add value, right? You add the values here. Accum plus values of t. And then the advantage here is the main thing. Row times rewards of t, gamma discount non-term minus values. And this BST plus 1 so they just took this the last term here is the value minus. So the last one of these is going to be this is 0, reward minus value of t. You're missing a term. This accum should probably start off as I'm going to try this. We still get exploding policy loss. This has got to be so close though at this point, right? Okay, so here, let's make sure we do this correct. So we absolutely know that this file's not the issue. Let's see this. What's wrong with logics being, like, why are logics zeros? That's super screwy, isn't it? Why is batch obs of 0? This not get filled up? Why, we're missing like a ton of observations in here, right? It's bizarre. I will double check in a second that this still trains with PPO. Advantages of samples. Do you get your batch? Okay. Actions. Shape. Shape. It's fine. Okay, so you have your advantage. Mean of, the way that they did this was oh, did you miss a log softmax? I think you missed a log softmax. Hang on. KL still broken. Logic should be just what comes out of the policy, right? Yeah. Target. We'll do target equals. Make sure there's not like a separate param or some weird thing. Yeah, you can see the KL still screwed up. Advantages dot detach. I don't. It's weird that they sum that, but it's definitely supposed to be a mean. Well, at least now we know that we have this correct, right? This has got to be solid. If you baseline, it's going to just be sum. Wait, torch.sum and compute baseline loss. So this is returns minus your value function. VS, returns equals VS, right? Value loss. Yeah, so this is good right here. We're happy with this. Yeah, we are happy with this. Now, we very, very carefully go through this one more time. Okay. You clip to a max of row threshold. Min. So it gives you a max. Delta is clipped row, rewarded time t, gamma, value at time t next, t plus 1, times terminal, minus values of time t. Then we assume deltas of t wait. Yeah, this is fine. So this is delta gamma c cum terminal. They have to reverse their thing because they did it weirdly. Vs accumulate plus values. And then what we did here is make sure broadcasted bootstrap values. Is this a different threshold? Clip PG row threshold? We should probably check this, right? Now these are both set to 1 here. We get row of t times reward plus discount accum minus values. The last value of this is going to be the last value we have here. We do all this and our policy gradient still explodes. It's a reasonable PG loss right there, right? So I'm not seeing the explosion happen instantly. So yeah, this policy loss is actually like pretty reasonable for quite a while. It does eventually blow up a fair bit. What about the was it old prox KL. So it's like 90 whatever percent clipping. Is it immediately 90% clipping? Yes, it's immediately 90% clipping. 60 or whatever. So what is this clip frac? Okay, so this clamp here, there's no clip that goes on this loss, evidently. Try to run PPO real quick. See if I broke anything. I did. Okay. This is PPO. We see small positive policy loss, very small KLs. Some clipping. That is what we should see. Okay, what is the original? Hello, YouTube folks. We are hopefully pretty close to having vtrace implemented into PufferLib. This would hopefully stabilize the advantage filtering stuff we've been doing, and also maybe just allow us to throw a little bit of off-policy data into the buffer once it works. Okay, so these are tiny, tiny, tiny numbers, right? Okay, so how is it that immediately these numbers are messed up? It's because you don't do... Hang on, when do you sample your batch? Sample. Okay. You sample your batch up here. Right? Hmm. Now I do wonder if there's something to this. Yeah, they shouldn't be diverged that much immediately. What happens if we, okay, it equals, what happens if we do this? Okay. So that actually does change stuff, but you still learn with PPO, right? So you start off with these approx KLs, like 0.5 and 0.2. You end up with a pretty damn high clip frac, but you still learn. And the KLs do not blow up. Policy loss does not blow up, value loss does not blow up, and it still works. So there's quite a bit of clipping. Maybe this thing not being clipped is the problem. So you, whatever I do, it's still, it just, the KLs blow up instantly. It's gotta just mean that the, I mean, we can print the values as well, right? These are not exploding. Yeah, so these are not exploding as far as I can see. It's the KL that blows up. State. Experience dot values. Yes. Wait, value equal batch dot values dot flatten. That's gonna unclip the value loss. But the V loss is not blowing up anyways, and that should be the more stable of the losses. What next? What do we try next? Maybe we go check. Let's go back to their code for a second, check a couple things. Because they have a couple different clip coefficients. Okay. This is clamped to a max. This is clamped to a max. This is clamped to a max. So PG advantages. Trace returns. Just a name tuple. Trace. So we do vtrace from logits. Target policy. Why do we have two different outputs here? Oh, this is just for the ratio. That's fine. Clipped rewards. The baseline here, bootstrap value. And then they compute policy gradient loss. They sum these together. Cost. Presumably they have a negative sign as well there on entropy. Targets. Multiply these. It's already detached. From logits here. Action log probs. Log probs. Difference. you get log rows, then you're going to immediately exp those. Entropy times advantage. Trying to think what we can even do to check this. Because this is identical. These advantages even look good. Let's see. Let's see if these advantages look good. Okay. Okay, so this is 0, and then why does this get bigger and bigger? Ah, because you get another one right here, right? That looks like pretty sane, reasonable stuff to me. Right. Yeah, actually tomorrow is good. Can be trace. Okay, so Isn't there's supposed to be a value bootstrap, isn't there? Am I wrong? Okay, so like that doesn't look quite right to me, right? So this gets no rewards, but it does have the value on it, right? Do you think you need the advantage normalization? It could be that, to be fair. We'll try that in a second. Let me just check one thing. So if you get no reward, what's the formula supposed to do? The way they have it, where's vtrace? All right, so the way that they have this, things I do to fix RL. Sake. This is going to be 1. This is 0. This is like 0.99 or whatever. So it's this minus values. So VST plus 1. So this should literally end up being like yeah, it's just going to be like this number minus this number. Same like that, right? Yeah. So a very small number is appropriate because it ends up being the value difference between two states. Let me try advantage normalizing. Let me try this. It just like it blows up instantly, man. See, now the KL's fine, but the value loss is screwed. Well, that is probably the thing that I broke from before, right? And just put this down here. So now the value loss is still exploding, just less quickly. And make sure that we still can train PPO on this. Okay, so this one still works. Does it work without value function clipping? Yeah, that seems fine, right? Okay. Maybe even better. Okay, so that might even be better. Clip the false. Really? Value loss blowing up? What was the value loss flipping? Clean RL? Clip the loss. And it's clipped to the clip coefficient, which is kind of funny. Yeah. Okay. So is the value loss just done now? Is that what's happening? Dispatch.returns versus new value. So we have new value. We have batch.returns. Set right there to VS. VS comma advantage. This thing has just got to be blowing up completely, right? Use value function. Look at this. I mean, this is the one that should be easy to get right. Torch.add this and then the values. So cum. It's values. Right? This thing should end up being pretty small. Yeah, it really should. Go print out the values. Mean values. Mean. We do not need this. Oops. Yeah, we can do that. Why not? Interesting. This just explodes. This thing just gets bigger and bigger. There's not even a sign difference? Wait. The fact that there's not a sign difference. Batch.values. That means that, like, the values and the returns actually kind of match. The returns just make no bloody sense, right? I mean, because all you're supposed to do is just, like, this. Right? Maybe I need to do this. Maybe this goes here. It's just gonna blow up. It's just gonna blow up. Okay. Why is it like this? like. That's cool. What do we think? And check against the math, I guess. Lambda. Hey, Captain. Been building a planter. I've been implementing vtrace all day. I like to be building a planner. That sounds chill. And maybe this one we can see. So delta plus gamma c does this need a minus? No. Right? Carpenter was showing me and a few other guys some tricks. TLDR vtrace. Replacement for generalized advantage estimation that should be better at off-policy correction, so it should allow us to get more out of the new experience buffer. Similar to generalized advantage estimation, it ditches the lambda term and instead it threads the important sampling term that's used for the advantage function, or used to scale, was it to clip the policy gradient? Yeah, instead it threads that through the advantage computation. Not max grad norm. It's a logit ratio of the new policy to the old policy before you started optimizing it this epoch. So that then means that the clipping term also gets applied to the clipping term gets like deeply applied to the value function as well, but not just like as a post hoc thing. What are you doing? I'm currently attempting to implement a CUDA kernel for this vtrace off policy correction / advantage estimate from Impala into PufferLib, so that we can leverage some like slightly off policy data with our implementation. Abandoning P30 for now, or do you think the new will experience buffer? So vtrace is still very similar to generalized advantage estimation, and like pretty much anything that I was going to do with P30 on top of JE, I could do it with vtrace as well. So vtrace still has the annoying the annoying gamma parameter, though arguably it should be slightly easier to deal with because it no longer has the lambda parameter. So actually, I think that probably once I get this thing implemented fully, this will probably be a little easier to work with for like P30 style stuff versus JE. How much testing of the experience buffer? Not a ton, but I mean, we've got results on like neural MMO stuff. Actually, that's soda right there. So there you go. That's soda with advantage filtering. So yeah, it's pretty good. The curves aren't quite as clean though, so we're gonna have to clean some stuff up there. But yeah, it's been pretty decent overall. Doesn't take much of an SPS. It shouldn't change the SPS at all. There's like one slight thing that we might have to consider when we do filtering with this, but it should be fine. It only screws over the SPS if you have like a 2 million step per second training run and then you don't implement a CUDA kernel for this. And lo and behold, CUDA kernel. I mean, we kind of should just go off of this reference, right? Where is it? I'm trying to think what the odds are that I just missed something in here, even though I've looked at it 10 times. Thamtaro. Just rapid fire, try a couple stupid things. I don't think that's needed, but... Oh, that blows up instantly. Okay. So now the KL blows up. Interesting. So either way, one of these two blows up. Where did that freaking implementation just go? There we go. T+1. Maybe this is an issue, hang on. So we do... T+1. So this gets all the deltas. Okay. And this accumulator that. CUDA compile times are a little silly. Okay, so that's interesting, right? The value loss is back to being mostly sane. Actually, both the losses are kind of like... Yeah, the losses are like kind of sane. until I guess the policy where the KL tends to blow up is better though. Okay, then maybe this thing's just really sensitive. Maybe I have some like really minor details screwed up. So the delta, you're missing the last delta, right? You're missing the last delta. PG advantages. It's gonna be on T next. Maybe I have this wrong still, hang on. Wait, I do have this wrong, right? I do have this wrong. Hang on, I think I see it. VST plus 1. Yeah. Alright, I gotta use the restroom and then I think I can fix this. I think I see it. Be right back. So here's the thing, right? This is Vs t plus 1. This should not be a cube. This should be Vs t plus 1. Or this one here, I mean. That's, which is going to start at 0. Possibly we're going to have to add the terminal bootstrap value. We'll see. This thing still immediately blows up. How many bugs do I have to fix before this thing behaves? Look at these KLs. Okay. Do I need this next non-terminal thing? Probably not. I don't think this fixes it though, right? I don't think that fixes. I'll run it, but I think we keep looking. Discounts. Rewards. Discounts. VS. T next. Values of T. Yeah, this stupid thing is just gonna keep breaking. Okay, let's think about terminal or bootstrap final value. So yeah, so it's just the last value, right? Vs t plus 1. Let's do Vs. See if that does anything. Exploding algorithm. Okay, I must have missed something else, right? Like, starts off at 0. Jeez. Okay, so delta, it's gonna grab t next, right? And then this accum, so this whole thing should be fine. Oh wait, the only thing is that the last VS is gonna be wrong. Hang on, that last VS is gonna be wrong. What's the last VS supposed to be? And it's supposed to be bootstrap value. It is. I just did that, right? Yeah, I just did that and that didn't make it, like that didn't fix it magically. This guy has a pretty nice paper. It's, was it Beyond the Rainbow? It's basically Rainbow, which is all the kitchen sink of tricks that they threw on DQM. Well, this guy found another kitchen sink worth of tricks to throw on it, and it did a lot better. This is discord.gg/puffer if anyone is interested. You want to get involved. We don't get a break on this thing. This still needs to get done today. I mean, they just used the bootstrap value at the very end, right? What's VS then? Dot add values. No, they do use it there as well, don't they? They use the bootstrap value at the end here as well. Primarily helps increasing action gaps and therefore reducing policy turn and off policiness. This policy isn't based on the value function directly, at least. Increasing action gaps. This guy had some very nice work. Soft Watkins. Am I getting trolled? I'm not actually getting trolled. Staying. Got a bajillion things in here. I'd love to see people using the algorithm as fast as possible. This would be a very cool guy to get involved with Puffer. Still have to finish this B trace. We don't get a pass on this. I do not know what's wrong with it though. Hang on, we are messing with this. He uses. I doubt you could get that speed. Okay, so technically this VT plus 1 could be off. Soda off policy uses fairly long traces. Meme uses 160. Interesting. Gradient steps extremely slow. LV play buffer. Not as good as BTR. Interesting. Well, I gotta read that paper for sure. I think we start with this thing though. When's this paper from? Is this recent-ish or no? 2022, not really. Each forward pass slows down a lot. To do so many forward passes kills. $2 weeks for an Atari game. It's crazy. It's not like one policy on everything, right? Yeah, it's still one each, I think. That's ridiculous. I actually think that I do have this right now, don't I? I miss the last delta, I believe. Yeah, I missed the last delta. What does that do? Missing the last delta. Do I have like some weird off by 1 on the advantages? Could be. I don't think so though. Oh geez, they actually roll it out like 160 time steps and then they throw away 159 of them. Crazy. You're updating a single Q value. I didn't try without normalizing advantages until since I did this, right? Um, I didn't try without normalizing advantages. Maybe you can't normalize advantages in this. That's one thing we could try. Eh? Did I really just casually do that? Hang on, is this the baseline? No, this is not the baseline. We just got V-trace working. Well, okay then. See if we can do, if we can get rid of this arc. Looks better, right? Off policy or bottlenecked by gradient steps more than anything else. Well, I think we can actually start benchmarking a little bit. That's awesome. All of a sudden, it works. Also, yeah, that's definitely soda. Spencer just got his box. Okay, it's not quite on par yet, right? But this is also no advantage filtering, like brand new thing that we just implemented. So next thing on this is going to be, can we filter? Well, let's make a commit right now because Alright, we're actually going to do some V-Trade stuff real quick. Though this guy is cool to chat with. I really wanted to have somebody with off-policy experience for a while, like actually like good off-policy experience, doing some stuff around in Puffer. And yeah, from that manuscript, this guy would be perfect for that. You can check out his paper. It's on Open Review, Beyond the Rainbow. It's pretty nice additions to Rainbow DQN, and pretty well done science too. So I think that all we have to do for this can we just copy paste this? Like, eh? Eh. 2 weeks to 12 hours. Apex stuff for BTR. I haven't seen Apex in a long time. God damn it. Distributed architecture. Okay, so the plan with this stuff right here would be how do we compute vtrace? I guess all we have to do is add log ratio, right? Find a style where you massively lower the replay ratio. Interesting. think all you have to do for experience, right, is you just have to initialize. You just have to initialize it to ones, right? Because, well, it is going to be 1 to start with, right? Wait, it's literally always going to be 1 to start with, no? I guess, yeah, initially it should just be. We can just do like, do like experience importance here, maybe? Right? Returns, advantage. A lot of my work focused on ends with fairly slow sim. Mm. 514 right now. I'm gonna try and implement this one ablation. I'm gonna order dinner. I'll dev for like half hour or whatever, get dinner, and then I'll come back for another couple hours. I think that's the plan. Well, this is kind of sketchy, isn't it? So this ratio, yeah, you don't actually know what this ratio is until you do the forward pass, right? Oh, that's not an issue though, is it? No, that's not an issue. Because then all you just do is you just do experience portents EX equal ratio. All right, perfect. So we finished that conversation. We get this is fine, right? Or is it not? It should be fine. And then, yeah, this should be fine. We'll see. Get some food as well. The amount of supposedly Asian food in Florida is very concerning. Where's this batch? Oh, this is experience. Experience. Yeah, that's fine. And this is experience dot returns. Must be 2D. Okay. I am actually gonna order food while I fix this because otherwise I'm gonna like, yeah. I think what I want. Actually, just real quick. It'll be quicker if I do this on here, assuming that I still have my credentials on this machine. And then we'll come back and let me order dinner, and then we'll get some cool experiments going, and I'll actually talk through stuff. I was a little distracted with that conversation, but okay. Yeah, we will actually get some cool experiments in. Gotta love how Florida, the average like distance to get food is like 10 miles. What in the heck? It's actually not bad. That's not a bad idea. Okay, local pubs got me. You order some stuff. And we will run these experiments. One second. Hey, Bet. markers wrong thing. 1 second. Just 2. Perfect. Okay, that is me taken care of. Let's get back to research. So, here's the thing with V-trace, right? It requires an importance ratio. The importance ratio, we're not going to deal with historical buffers for now, but it should always start off as important ratio 1. Because it's the ratio of new policy logics to old policy logics, and at the start of an epoch, new policy equals old policy. So we should be able to do something like that. Oh yeah, and now we just have to debug some shape stuff, and we should actually be able to compare this to what I was doing earlier. This is the issue. I just know that's the issue. Here, let me just fix that. This needs to be appearance dot spread values dot shape. We'll just do that. We can call this advantages. No reason not to. Experience stop returns. Experience stop returns. Okay. What is BTR paper? Hey, where's the hell? It's beyond the rainbow. It's this. Yeah. Yeah, it's this thing. There's, I guess it is on archive then. There's an archive version. I was looking at the open review version. From the format, it looks about the same. So we had author of that is in the Discord. That's the goal eventually, is just to have all the cool RL people in the Discord. So whenever I have a question about anything, it's just like, they're all right here. Oof. So, what we're fucking with at the moment is not quite off policy. It is an off policy correction technique applied to on policy. Yeah, that didn't freaking work now, did it? Batch. Is it like batch.advantages? PPO arguably has an not except for the dev branch, it doesn't. I mean the buffer branch, not even the dev branch, the more recent branch. Okay, so we do actually have advantages in the buffer. Perfect. So now this has actually got to be experience. Where's it? Batch dot advantages. Okay, it runs. Still on random sampling. It crashes, really? Okay. Well, I have a bug. Do I have a bug? Hang on. Or am I not being smart about this? So every mini batch, we recompute vtrace. With experience.importance. Right? We sample from advantages. And then if we're going to use vtrace, experience.importance. No, not this, right? It's not ratio. Actually, this shouldn't matter though, right? Wait. No, this is correct. Importance is equal to ratio. Yeah, this is correct. And it should be logits, actions, huh. That's unstable, really? All I did was, it's still on random sampling is the thing, so that advantages shouldn't factor in. It's really weird that that is unstable. Let's just make sure we didn't get unlucky. I don't think so. Okay, so compute your advantages, right? No, we didn't get unlucky. The KL blows up. But it's weird because do I just roll this back? Hang on, do I roll this back or do I just compare? It's a good thing, and this is why I made a commit. 15, 20 minutes before food. I'm getting very hungry. Okay, so on file. PufferLib. Clean PufferLib. Puff puff. Good time to remind folks. If you want to help me out for free, just start the GitHub. Almost at 2K stars, and it really helps. There are not that many RL repos with 2K stars. Especially not in like 1 year of full-time dev. Okay, so in this one here, I gave it ones. And I sample. But this shouldn't matter because it's random sampling anyways. Right? And then in here, vtrace, yeah, star the buffer. And then here we get vs advantage top values. What is the difference between computing it here and then elsewhere? Oh, hang on. Yeah, no, you can't do this. The importance ratio gets stale this way, right? Yeah, the importance ratio gets stale. Okay, so I have to go back. We go back to this. Yeah, we go back to this. We make sure this still runs. And then what we can do let me see how prioritized experience replays update formula works. Okay, so they use TD error. And then they update the priorities with a new TD error after a learning step. So TD error Do you have to hang on, when you prioritize this thing, your value, this is gonna get slightly stale, right? But the key is it only gets stale for yeah, it's better to make that okay, that's fine. Yeah, I see it. I think I see it now, folks. I see it. So we have disadvantages here. I guess we just take importance, right? Okay, so we do importance. It's going to start uniform. Use importance. This will be importance. And then where is it? Experience. Experience. Or is it just importance? I think that'll do it. It's not a Neptune log. Shape mismatch, eh? Oh yeah, this importance doesn't need to be. Yeah, this importance needs to be data.experience rows. Right? Yeah, that's the importance. Holy. Yeah, okay. Oh, I think that it does. Okay, force.1's like. Okay. So this should still work. Like before. Come on. just getting hungry. Size. Oh, it eats the batch advantages, doesn't it? So this is just advantages. Whatever, we do this. Okay, this runs, right? Does it explode instantly? No? Okay, we track this. And we see if we have broken anything or not. And if we haven't, the key thing is now we should actually be able to add in the advantage filtering. Here's our run. This should be like about what this yellow curve is. One minute 80 mil step training runs are very nice. Yeah, okay, this looks like this is about the yellow, right? It's already up to 7. Yeah, so this is about on par with the yellow curve. And there's some variability, so it's fine. Now what we get to do, delete this line, rerun it. We should have importance sampling. Which we would hope would be better. At least don't be worse. Okay, good. Yeah, this is what we want. This is what we wanted to see. I think it is better. We gotta wait for the curve, but I think so. Okay, yeah, that is better. Perfect. So then the question is gonna be, right, ten-ish. Oops. Do I add this to the experience buffer? Probably, right? and then we do experience. And then the importance gets updated to this. And the only other thing we have to do is we have to remember to 0 it. Or 1 it, I guess. Reset it either way. Rerun so that we make sure we didn't break anything. And then we will run with replay. This is experience rows. Food is here in like a few minutes. 2 more experiments. And then that'll set a decent tempo. I don't expect the off policy to work immediately, by the way. I don't expect it to work immediately. I just wanted to have vtrace, and now we have vtrace. Which technically kills a hyperparameter. If it matches in perf, it's better just because it kills a hyperparameter. Okay, that looks good. Now we set replay factor equal 1. Set like 0.5 maybe. 0.5 should be plenty. Okay. Last experiment should be replay factor 0.5 means it's allowed to keep up to half a batch of data across epochs. So it is actually allowed to use fully stale data. Yeah, I think it's going to be the same stale result here. How long is it keeping it? As long as it likes. It's based on, well, it should be based on a priority metric, but we got to improve on that. Okay, so this does not, vtrace does not magically let us use off-policy data yet. We will continue to work on that. We will get an actual proper prioritized replay buffer, and we will do some other stuff for that, though. Change the 05. Well, that was the point of the test, to see whether you could use, yeah, that's fine. All right, I will be back after dinner. Probably should be back after dinner for at least like an hour or so. For folks watching, Puffer.ai for all my stuff. Reinforcement Learning Dev live almost every day. Started the GitHub to help us out. It really helps. We've got lots of fun demos on here. Lots of different games, all with neural nets that run in your browser. If you want to get involved with dev, join the Discord. Some of our best contributors came in with 0 RL experience. And you can follow me on X for more reinforcement learning content. It's all RL all the time. So thank you, and I'll be back after